This kind of equipment is the data acquisition equipment. This is probably one of the better facilities we've been able to build because it allows us to insert complete Traxel systems inside there, control temperature. This particular one didn't spend a lot of time with, but it's the same kind of environment, trying to measure how the sound waves, the acoustic waves, change in a core as you put CO2 through it. A lot of the research area in this lab in terms of equipment is really involved in sustainable ways in which we recover oil sands. PhD students can have an experimental component to their research, and this provides an environment to do some pretty complex testing.
This is a testing cell that's going to be able to replicate the stress and fluid pressures at 1.5 kilometers underground. So this is one of the areas where people are looking to store CO2 in coal beds deep underground. So one of the advantages of coal is it stores methane gas, so when you inject CO2 into it, the CO2 pushes out the methane and replaces that space with CO2, so you get an advantage of exchanging CO2, a greenhouse gas, for natural gas, a more clean burning energy. So you'd have an injection well and a producing well, so you kind of push the CO2 in, methane along, and out the other side and capture that. So that's what this test is for. It's going to tell us a little bit how the coal is going to behave when you exchange the methane for the CO2.
To confirm that CO2 storage can be done safely at that scale, a really important lesson, and there are lots of people working on it. And I think in our group, we're just happy to be a part of that group that's contributing that knowledge to that, because that's a big thing.
You know, everybody says, think globally and act locally, so this is exactly what we're doing. It's exactly what I've been able to be a part of since moving out here. I'm actually applying myself to solve a problem instead of just complaining about a problem or observing a problem. Can you get me 2 7/16?